The traversing is a process of accessing each node of a linked list exactly once to perform some of the operation. P1 will going to be null. P1 hold the address of P2, but as of now P2 is in the last node, so its pointer location will be null. Linked list element may not be stored in contiguous memory. So why? Because the pointer at each node will going to help us in order to identify the location of next node. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of chapter 1, and we are in the unit 3 of B.Ca's second semester subject called Data Structures using C. I'm Rohini T.S., Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. Before getting into our today's session, we'll just have a quick recap of our previous session. In the last session of this chapter, we had a discussion regarding linked list. So we got to know what is linked list, and also have discussed regarding what are the types of linked list we have. So in our today's session, we're going to learn what are the operations can be performed on the singly linked list. Along with that, we'll see about the memory allocation as well as garbage collection. This is what I will be discussing in my today's session. We'll have our operations on a singly linked list. As we all know that we can perform traversing of an linked list, and we can also create a linked list, we can insert a node to a linked list, we can delete an element or a node from a linked list, and we can also search the node of a linked list. Those are the operation we can do. So amongst that, first here I have a creating a linked list. If I wanted to perform any of the operation, first I must need to create a linked list. Already you know how linked list will going to look like, right? So it will going to have two fields. One is info, that will going to have a information or a data, and we have one more field called link. It will going to hold the address of next node. So if I am considering this as node 1 and node 2, this node 1 link will going to have address of next node. So when the node link become null, then I can say that that is the last node of a linked list. That's what basics of linked list. Then how we are going to create, what are the things needs to be there in a linked list? We must have a info as well as link. We'll see how we are going to create that. The nodes of a linked list can be created by the following structure declaration. So we are creating a structure which will be helpful in order to create a node as well. So here struct, and struct name is node, and it will going to have int info. I'm taking a info as a variable of a data type called integer, and I'm creating a node which will going to have a link. That is what here we have a pointer variable that will going to hold the address of next node of a linked list. And here you can create any number of nodes that you wanted to create. So mainly we are going to use a structured data structure that will going to have a collection of heterogeneous elements. If I say array, that will be a collection of homogeneous. Same kind of elements must be there in the arrays. But if we are having, or if we are creating a node with the help of this structure, it can have different types of data elements in it. That is what the reason. Here I have a int, and also I have a struct data type. That is what we are creating it with a heterogeneous elements. So in this way, we are going to create a node. So here you can see that info is the information field and link is the link field. This info will going to help us in order to hold the data, and link field will going to help us in order to find out the address of next node of a linked list. Next, what we have, that is traversing a linked list. What do you mean by traversing? For example, if I just have a 5 nodes in my linked list, I need to visit each node from the beginning to the end of a node. So that is what we are calling it as a traversing. The traversing is a process of accessing each node of a linked list exactly once to perform some of the operation. That can be insertion, deletion, merging, sorting, searching, whatever could be the operation. I'm visiting each node exactly once, or at least once, from the beginning to the end. Then we are calling that process as a traversing here. So here you can see the algorithm for that. We have a traverse, that is the name of a algorithm. In order to traverse each node of a linked list, I require start and p. If I don't know which is the starting node, then how can I start traversing? So I must know the start, and we have a P. That is what? The temporary variable which is used to visit all the nodes from the beginning to the end of a linked list. The start will going to have a address of the first node of a linked list. Okay. If I get to know what is the starting node of a linked list, then it would be easy for me to traverse from the beginning to the end. So fine. Next, what is the first step here? P is equal to start. P is a pointer variable that will going to hold the address, right? So I need to assign the value of start pointer to the variable called P. I need to give an address of start to the variable called P, which will going to hold the address of this starting node. If I get to know that, then I can move to the step 2. While P not equal to null. Already I discussed, right? So if I have 2 nodes in my linked list, so if the link of any of a node in a linked list become null, then I can say that that is the last element of a linked list, or that is the last node of a linked list. If the P is not equal to null, that means what? We are not in the end of a node, or we are not at the end of a linked list. We have some more nodes in our linked list. If this condition becomes true, then process data of P. That indicates what? If you are not at the last node of a linked list, I need to do the traversing. That is what? It's mine. So in the step 3, we have to process data of P. From the beginning of a first node to the next node, next, until I got the P as a null. If the link of that P indicates as a null, then I can say that as a last element. Until that, I need to traverse from the beginning to the end. After that, P is equal to link of P. So we are going to copy the link to the P and end of while. Then we have to return back. This is how we are going to traverse. So now we got to know what is traversing is all about. Now we'll say about the searching in a singly linked list. What do you mean by searching? First of all, if you are finding a location of any element or a node of a linked list, then we can say that as a searching. So you can see here, searching is performed in order to find the location of a particular element in the list. Then searching any element in the list needs traversing through the list and make the comparison of every element list with a specified element. What it means? For example, you just imagine I have 5 elements, 10, 20, 30, 40 and 50. Okay, so these are my elements of a list. So now I wanted to search the location of this 20. That 20 is my key right now. That means I wanted to search the location of this 20. Then what I'm supposed to do? I need to traverse from first element to the last element, whether I'm going to find it or not. That is what I'm searching, the location of a particular element. So in this example, 20 is the element that I'm searching for. Then I will compare 20 with 10. Is 20 is equal to 10? No, right? Then this is not the element that I'm searching for. Next, I will move to the next element. Is 20 is equal to 20? Yes, I found a element which is at the location 1. Because it starts with a index 0, and you can say that the element locate at the position 1. This is how we are going to search for the element. And also, if the list element is matched with any of the list element, then the location of the element is written from the function. So here I found the element, that's why I'm going to return the location of this element what I was searching for. So we'll see the algorithm here. First, set PTR is equal to head, from where I'm supposed to start the traversing. So head and start both are same here. I need to set the pointer to the start or head. Then I will be able to understand which is the first node of a linked list. After that, set I is equal to 0. We are starting with the iteration 0. I am in the first node, that's why I is equal to 0. After that, if pointer is equal to null, then that means if the pointer, we have a info and link is a pointer. If the pointer variable is equal to null or P is equal to null, then I can say that we have to write empty is list. That means we don't have any element in order to traverse, or else we have to go to step 8. That means we have to exit. So if the pointer is equal to null, or if it is indicating as a null, then we can understand the linked list is null and we don't have any nodes over there. That's why we have to exit. After that, we have to end the if this pointer is not equal to null. So if that is another case. So if the pointer is not equal to null, then what we are supposed to do? Come to the step 4. Repeat the step 5 to step 7 until the pointer is not equal to null. When I found all the elements, or when I have a last but one element in the linked list, till that I need to traverse. When I found the pointer variable as a null, at that time we have to exit. Otherwise, I need to start traversing from first to last element in order to find out the address of specified element. Then here you can see that if pointer of data is equal to item. So, if the pointer is pointing to the data which I am looking for, or the searching item is found in that, then we have to increase the iteration by 1. So, initially I was 0. Now, I am going to increment the I by 1. So, now I become 1. That means it will going to check for the second element. Then, end if. So, this is how it will going to find out the particular element or particular node of a linked list. Then I is equal to I plus 1. We are keep on incrementing the I to the next node of a linked list. Then here you can see that pointer is equal to pointer next. So if I wanted to traverse, I wanted to know the address of next node. Then this pointer will going to help me in order to find out the address of next node. Then end of for loop here. After that, we are going to exit. This is how we are going to search for a particular element in the single linked list. Next, you can see the insertion operator here. That means if you wanted to insert an element into the linked list, it can happen with 3 ways. I can insert an element at the first, and we can add the element at last, and we can also insert a node at the specified location. So, these are the different ways we have in order to insert a node into the linked list. So, here we are concentrating in order to inserting a node at the beginning of the linked list. For example, already I have a linked list. So, you just imagine already I have 2 nodes. Let me consider N1 and N2. It will going to have address of next node. Let me consider 10 and 20. This is null. That because it's indicating it's the last element of a linked list here. So here I wanted to insert a element at the beginning of a linked list. That means what? I wanted to have a new node which I wanted to have that node as a first node of the linked list. That is what I am trying to do in the insertion of a node at the beginning of a linked list. What we are supposed to do? First, I have to create a node. Already we know, right, how we are going to create a node with the help of structure? Yes. After that, fill the data into the data field of a new node. So here, you just imagine I am creating a new node here, and you already know that head or start will going to point to the first node. Fine. Then here I am creating a new node. There, what is the second point? Fill the data into the data field. Let me consider it as 30. Okay, fine. Next, mark its pointer field as null. So, I need to make its pointer field as null here. After that, what I am supposed to do? Attach this newly created node to start. I need to attach this node, newly created node to the start. So, here it will be attached. That means we are adding or we are attaching a new node to the starting node and make a new node as a starting node. If I am making it as a starting node, then it will going to hold the address of a head or a start. That means it will going to hold the address of existing first node. So, as of now, it will be the first node, this will be the second node, this will be the node number 3. This is how we are going to insert a node at the beginning of a linked list. So, here you can see the algorithm here. Insertion of beginning, start P. I wanted to know the starting point, then only I will be able to add the new node to the existing list. It require a pointer here. Start contains the address of the first node. If I found the address of first node, then it will be easy for me to add the new node to the existing linked list. So here P new node. We are creating a new node and I am giving the address to the P, and data of P is equal to num. That means I am giving some data or information to the newly created node. That is pointer is pointing to the new node. To that new node I am giving a data of integer, and link of P is start. We are pointing the newly created node to the start of a linked list or a head or starting node of a linked list, and now this pointer will going to point to the start. That means it becomes the start, and whatever the existing start was there, that will be the second element after the insertion of new element into the linked list or new node to the linked list. Then we have to return back. This is how we are going to insert a new node at the beginning of a linked list. Fine. In the same way, we can also have a deleting an element or deleting a node from the linked list. So this can also be happen with three ways. We can delete the first node, or we can have a deletion of a last node, or else I can have a deletion at the given position. So we're going to concentrate on the deletion of the last node. So insertion at the first node and deletion of a last node will be important when it comes to the linked list insertion and deletion operation. Already we all know that deletion is what? Removing a node or element from the linked list. We are going to call that process as a deletion here. We'll see the algorithm. I'm deleting the end node of a linked list. For that I require three variables P1, P2 and start. Start you already know, in order to shows the head or point start pointing of a linked list here. So this use two pointers P1 and P2. Why we require P2? Why I require P1? We'll see now. Pointer P2 will going to use in order to traverse the linked list. So if I wanted to delete whether it is a first element, last element or a specified locational element, so I must traverse from the first to last. So in order to traverse, I require a pointer 2, that is P2, and we require a pointer 1 P1 which keeps the location of the previous node of a P2. So this will going to act as a tail for the P2. So for example, if I have three nodes, if I have three nodes here, if I have three nodes, if P2 is here, then P1 will going to hold the address of the previous node. For example, you consider P1 is here. This is holding the address of previous node. That is what the reason why we require the P1 and P2. P2 is used to traverse. So first P2 will be there. Next we have a P1. P1 is having the address of previous node. So first we have to start, then P2 start. We have to start traversing from the beginning or a head. That's why it start. Then while link of P2 not equal to null. That indicates what? P2 is not at the last node. So it is in the first or any other node, but it is not at the last node of a linked list. If it is true, then P2 of P1. That means the link of P2 will be copied to the P1. So always assignment will be from RHS to LHS. So here P2 is having an address of a particular node of a linked list. This P1 will going to hold the address of P2. That means it specifies the location of a previous node. So here that P2's location will be copied to the P1. Then link of P2 will be there in the P2 itself. So if this condition become false, so if the link of P2 is equal to null, if it is at the last node, if it is at the last node, at the time what we have to do? We have to end that while. Otherwise, print data of P2. So if P2 is here, if it is starting from the start, then I am going to display the data as 10, then it will be the 20, 30, then it will display 20, then it will display 30. So once it found the null, link of P2 become null. So once it reached the last node, then it will be null. After that, we are not going to print it. Then null is equal to link of P1. So if this P1 found a link as null, so when this P2 comes to the last node, at that time this pointer location will be null. So that P1 will going to be null. P1 hold the address of P2, but as of now P2 is in the last node, so its pointer location will be null. If that is the case, then we have to free the P2. That means I need to delete the last node. So P2 will be here. P1 is waiting for the address of P2. Then this P1 found that this P2 is at the last node of a linked list. Then it will going to be removed or deleted from the linked list by making use of this free function. Then we have to stop. This is how we are going to delete the last node of a linked list. So here you can see that memory allocation of a linked list. So already you know the memory allocation of array, that is of contiguous memory location. So if it is in the 1001 location, next immediately it will be in the 1002 location. But that is not in the case of this linked list. Why? Because linked list element may not be stored in contiguous memory. So why? Because the pointer at each node will going to help us in order to identify the location of next node. This is not what sequential orders memory location. So here we have a pointer. That pointer will going to hold the address of next node. With the help of that, we will be able to manage the memory of a linked list. So here linked list takes an extra memory space for the pointer. So we require more space in order to hold the pointer. That means if you consider the array, stacks and all, there we don't have any pointer. Fine. So there we don't have extra space for the pointer. So we just have a space only for the info array data. But in the linked list, we also have a pointer variable that will going to point to the next element. So here what we are going to do, this pointer will going to help us in order to hold the address of next node. That's why it will going to take a extra memory space. But on the contrary, most of the cases, array might end up with a memory allocation but not used. So I may going to create an array int a of 50, but I may have not used all the 50 memory allocation, but that will not be the case in the linked list. Only if I have a next node or a next element in the linked list, then only it will going to hold the address. So that memory utilization will be very well in the linked list. So linked list scores the extra points here by having a efficiently occupying the space only it is needed. So this will going to have a very efficient memory usage of a linked list. We'll see the next concept, that is operator new and delete. Why we require the operator new and why we require the operator delete? You can see here, operator new will going to allocate the memory space. And if I have a new of a square bracket open and close, that indicates what? We are allocating a memory space for the arrays. Fine. Then in the same way, operator delete will be going to deallocate the memory space. Whatever the allocated memory is given to the particular data elements of a linked list or whatever could be the programming elements, that needs to be deallocated or freed once the usage is got over. So that will going to be done by this delete operator here. Then operator delete will going to deallocate the memory space which is allocated for the array, that too by making use of new here. This is how operator new and delete will going to help us in order to have a very good memory management of a linked list. Next, we'll see about the garbage collection here. So why we require garbage collection? So if I say garbage, some dirt things comes to your mind, right? So whenever we have a program, we have to allocate a memory space, right? Once it got over, once the usage of all the variables got over, that needs to be freed from the holding of resources. That means we have to reuse the resources and we must have a efficient memory usage of a computer's memory. That can be done with the help of this garbage collection. So being a user, sometime I may forget in order to release the resources which was held by the particular programming elements, but this garbage collection will going to help us in order to deallocate the memory space automatically once the usage of that memory space got over. Then we can allocate that memory space for the reusage purpose and we can use the resources which was held by any other programming element. So here you can see that garbage collection GC is a dynamic technique for memory management and heap allocation that examines and identifies dead memory blocks before reallocating storage for reuse. So, in order to have a efficient memory management, this garbage collection will going to help us in order to identify and examine the memory blocks which are free. So then that free memory allocation space will going to be allocated for the resources or can be allocated for the variables which is in the need. So garbage collection's primary goal is to reduce the memory leak. Memory should not get wasted. So that needs to be utilized properly. That is the main goal of this garbage collection, and it frees the programmer from having to deallocate and return the objects to the memory system manually. Anyway, as I told earlier, this is an automatic way of managing the memory resources so that whatever the objects got its resources, once the usage of that resources got over, that will going to be freezed by this garbage collection technique and can account for a considerable amount of program's total processing time. So if you are having this garbage collection, this will going to help out in order to reduce the total processing time, and as a result we can have a significant impact on the performance. So if that is not a overhead to the programmer, we can have a efficient usage of a memory, and also we are going to use this garbage collection for the purpose of stack allocation, region inference, and also memory ownership, and combination of various techniques are the examples in order to have this garbage collections. And also you can see here, it's a technique or a memory recovery feature built into programming language. So you can see this garbage collection or automatic memory management in the language of object-oriented programming like C++, Java, .NET, there and all, we can have this garbage collection technique. And the main basic principle of this garbage collections are finding the data objects in a program that cannot be accessed in the future and reclaiming the resources used by those objects. So if you are unable to access any of a programming objects, however or how much resources can be fetched from that existing object will going to be done with the help of this garbage collection. And also we have certain techniques in order to maintain this garbage collection, that includes mark and sweep, and we have a reference counting. I hope you all understood our today's session. It's all about our today's session with respect to the linked list. In my coming session, let me discuss about the chapter 2. That's all regarding trees. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.